Hello everyone, welcome to Course Seeded. So today we are going with the lecture 2 of Maths plus Code in C++ for data science, obviously. So over here you can just create this, go to Google Colab and then sign in with your email ID. And after that you can just go to this section. And then you can use a hash for heading, double hash. And then you can write course. You can write your name over there, or you can write whatever you want as the topic, and then you will get this code functionality over here where you want to check whether C++ is installed in your computer or not. Now suppose if this shows some error, then what you can do, to download in Google Colab, you can just use apt get apt-get update, and after this what you can do, you can write apt-get install. So after doing this, you are given it permission to install G++ on your this Google Colab of your email. So after doing this, you have to just recheck whether you have this C++ or not. So what I'm basically saying, if you don't have C++, use these three codes. If you have, if you want to just directly check, you can just use this code. So let me delete all of them. So next we have okay, so this is course seeded data science course. So over here we have, well, let me just remove this, and then what we can do, we can add new section over here, and then we can just use double hash. So if you remember HTML, so what we do for h1, h2, h3, we just write h1, 2, 3. Over here hashes tell what type of heading you'll have. So h1 means single hash, and h2 means double hash, and so on. So that's how it works over here. So over here we can write data science course, data science course, and after this what you can do, you can add a new line of section where you can write with 3 hashes or 4 hashes, you can write linear algebra. So yesterday we did almost everything in maths for linear algebra. So here we'll be writing code to implement all that. So at first we have this data science course, linear algebra and all that. Next what you can do, you can just create a file, C++ file. So to create that, you just have to come over here. No, not over here. Let's try to create that. So not over here as well. So we can create a new file. Okay, so it's currently not loaded over here. Okay, so I have this much available space in my current this. I don't think I need this, so I'll be deleting this file. So let me just recheck whether I have G++ or not. Yes, so I have that. And after that, what you can do, you can just new file. So let's remove from here. So we don't need this either. So let me just refresh this. Or we don't need this as well. So first we have, so I forgot how to go back in this. Actually, I'm using Google Colab after a long time, or you can say I have never used Google Colab, but similar thing. But yeah, this is new to me as well. We don't need Colab, Kaggle or anything. Yeah, so okay, so let's just come over here. We don't need to upload, we just need to create a file, but how? New folder I can create somewhere. Okay, so let's write, or I can just delete this folder. Oh. Yeah, so over here we have this. So we have data over here. So over here we can directly add this new folder where we'll be writing our code, which will be, I think, we will be naming this data science course by course seeded. Data science, or let me write course. So course seeded over here. After this, what you can do, you can just open this file, and over here we can add new folder where will be over here you can write your own stuff, your name as whatever you want, and then you can write data science with C++. So after doing this, okay, so after doing this, what you can do, you can add a new file, or we can just name it library. Afterwards we'll be doing that. So for now we'll be just naming it rename file. Let's say we have main.cpp. Well, cpp is the extension for C++. So we have main.cpp over here, and then we can write our code, whatever we want to include or not. So we can go with include. Wait, so why is this still untitled? Yeah, so we have this. So instead of writing over here, we can instead write here as well. But what we need to do, we need to first open, let me delete this. Yeah, so over here we can just copy this path, and then what you can do, obviously you have to copy the path for this so that you can compile it over here, and then you can check what it'll show over here. So at first you have this start coding. Next, what you have, so what you'll be doing, you'll be just writing few code over here, and then after that you'll just compile it over here, which will be your not G exclamation G++, or not G++, whatever you want to call it. So it will be our main.cpp, and then as an output file we want, instead of writing hello, we'll be writing data science. No, actually we can write this main library, or we can just write main for now. So let's compile this for now, and then what you can do, /main. So this basically you have to write for this is a bash command or terminal command, and then afterwards you can just write normal terminal commands as you write in the terminal. So this is your /main, which is your like for opening this you will be just, oh wait, okay, so we had to just wait a second, you have to provide this and then output the main over there. So let me just press enter over here. No such file or directory. Okay, so copy path, Let me use these things. Let's see if id return one exited status undefined reference a reference to main. Okay, so we have to change this as well. So okay, so let me think first what this says. User library gcc and then all this. Afterwards you have in function underscore start undefined reference to main. Okay. So over here we have maybe we need to write path as well. So for path, I don't think we just directly output as in the path. Well, let's no, instead of writing all this, let's just say we want a main. Okay, so we also need a path. So well, let me think first. I forgot what the command was. So actually we are compiling over there and then we are trying to output a file named main. So it shouldn't be a problem at first. But looks like our main doesn't includes anything. So let me write some code first. Well, let's first write the code so that we don't get into much trouble. So we'll be just printing hello over here. So let's save this first. Okay, it's saved already. Okay, so it's saved. That was actually something unexpected for me, I would say. But yeah, let's go with this. So okay, we are getting the output. So it must have saved somewhere where we don't know. Let me just find where it's saved. So let me just find where we are right now. So for that we'll be using ls or okay, so we have sample data somewhere main. So we don't have any main over here. Okay, so that's actually complicated. If we don't have any main, then where are we actually? Okay, so not in the bin actually, but maybe in the content we are. Yeah, so in the content we have this main. Okay, so everything will be saved in your content. Otherwise you can change the path as well for the output. You can just type somewhere in over here and then you'll just get what your terminal command should be. So that we so let's leave that for now and start writing the code here. So at first we have this main.cpp. Next what you can do, so let's write few C++ functions and then we can just save them everywhere wherever we need. So actually I forgot what I was to teach you all today. Okay, so I need to check what we have studied. Just give me some time, I'll be back. Okay, so I was about to start very basics. I mean the basics of basic. So at first, let's go with the number system, which you already know, but let me just quickly tell what natural numbers are. So natural numbers are represented by n, and they start from 1 to n. Sometimes whole numbers are also called natural numbers, sometimes in few textbooks, but let's not call them over here as natural numbers. So this is your natural number, and you have it from 1 to infinity, and for every x belonging to n, it is x plus 1. So you can write this as a set rooster form, or you can just leave it like this over here, like this, 1 2 and 3, and this will be your pattern which you'll be writing at first. So for natural numbers, you have there are infinite natural numbers, so infinite n natural numbers, or you can just leave it as n. At first, this is your infinite natural numbers, then you have they are positive, sometimes non-negative, you can say. I mean, if whole number is included as natural number, basically what I want to say, if 0 is also included, then you can write that. Otherwise, you always have to write positive in form or in nature. So, or you can just write they are positive. And then you have they are closed under addition and multiplication. Basically, you can add and multiply to get another natural number, but subtracting doesn't mean you will always get in addition and multiplication. So these are closed in addition and multiplication. So for example, you have 7 plus 7, this will be your 14, and suppose you have 7 times 7, this will be your 49. But suppose you have 7 minus 8, this will be your minus 1, which is not a natural number, so they are closed under addition and multiplication only. So we have this. And suppose if I talk about integers, which will be your represented by z. So z equals your this minus 3, minus 2, minus 1, 0, 0, 1, 2, 3, and so on. And then next you have some examples. So examples obviously you can see over here. So let's say, can you so what are the properties for this? So obviously all these properties will be will also be applied to them for integers. So it will be your like infinite integers exist, positive, negative, as well as 0, positive, negative, and 0. So you can just see over here. And for and they're closed under addition, multiplication, and subtraction. So basically they are not closed under division. Suppose you write 2 by 3, that does not give you so suppose you write 2 divided by 3, this will not be an integer, so they are not closed under division. So these two you now know what natural numbers and integers are. So at first you have them. Next you have rational numbers. So rational numbers, obviously you will get a few things that they are closed under division as well, and rest you can think yourself. So closed under division as well, so what are the properties of rational numbers? Suppose you can write p by q belongs to rational number. P by q belongs to rational number if or where, you can say, if p belongs to integer, and if p comma q belongs to integer, and and obviously your q is not equal to 0. First condition. Otherwise, you know that it's infinite, or you can say undefined. So yes, this is your p comma q belongs to integer and q does not belong, q is not equal to 0. So this is your definition for rational numbers. So you also have decimal form for rational numbers. So decimal forms are obviously you all are familiar with them. Decimal form is to which is your 3.2, 2.4 and all. So 2.45 equals 2.450, but 2.045 does not equal 2.450 or 2.45. Yeah, so basically, and this much you already know. At least that's what I expect. So after this, you should also know about irrational numbers. Irrational numbers. So irrational numbers are your root 2, pi, and so on. Now suppose, so let's include e as well, which will be your 3.14 something. So let's not write the the actual value because that's never defined. So you have root 2, pi, and e. So these all are irrational numbers and you can never represent them in a decimal form. I mean, they'll just keep going. So you have this root 2, pi, and e. So sometimes people think that 1 to 4 is not a rational number. Obviously, it's not a irrational number, it's a rational number. But suppose if I say that this keeps going, what do you think? It is a rational number or irrational number? 1 to 4. So remember, any number, any decimal format which can be represented as p by q form, where p is your p comma q belongs to your integer, and q is not equal to 0, you can say that it's a rational number. So can we form this? So let's try that. Suppose x equals 3.124, and then you have let's say 10x equals 31.24. So for this you can write 31.24 minus what, 3.124 divided by 10 minus 1, which will be your 9, is equal to x. So let me just directly write 9 over here. Okay, so since there are 3 numbers, or you can say many more numbers, so since it goes with this, so let's, instead of actually I should have multiplied by 1000 because 3 numbers are repeating again and again. So this will be your 999 and this will be your 3124.124 bar minus 3.124 bar. So you obviously know that this will be equal to this side because they'll just keep repeating and subtracting each other. So we don't need to care about that. So you can just write 3121 by 999 is your x. So since this was this, we were able to represent that as a rational number. So you can say that this belongs to, x belongs to rational as well as irrational number, which will be your irrational. Actually, I forgot what symbol was for irrational numbers, or maybe there was no symbol. So we have x belongs to q and irrational number. So all rational numbers are, I think, irrational numbers. Okay, so no, irrational numbers are basically not rational numbers. So I just remembered that. So x belongs to q, but x does not belong to a rational number. So you can say that x belongs to rational number instead of belonging to a rational number. So we have this. So this was your rational number and these were your irrational number, root 2 pi and e. So after that we can move to real numbers. So real numbers are your, obviously you all know what real numbers are. which can be plotted on a graph are your real numbers. So sorry, not on a graph, but on a number line. So this will be your real number, whichever can be plotted on this single line, and complex numbers, whichever can be plotted on a graph, on a 2D plane, you can say, where this axis is your imaginary axis and this is your real axis. So at first let's learn about real numbers. So obviously they have all the properties listed over here. They are infinite in number. They are infinite in number, and they are positive, negative, and 0, and obviously decimal as well. So closed under addition, multiplication, and subtraction, and division, and so on. But can you guess where real numbers fail? I mean, where they are not closed. So suppose if closed under all that, and where they are not closed. So let's try to find that out. So suppose if you write x equals to root minus 1, it is impossible to like find whether it will be your whether you will be able to get minus 1 if you multiply anything. So obviously it's impossible to get this as a square of any number. So you can't just write root minus 1 over here. So instead we perform something that we'll be calling minus root 1 as iota. So let's write complex numbers over here. Complex numbers, which are represented by C, I think. Yeah. And this by R. And this will be your capital C. So we represent minus 1 root of minus 1 as iota. So this I is called iota in terms of a complex number. Iota. So next we have what can you do with this iota? So if suppose you have minus of this, so you can write root of minus 1 times root of 2, which will be your iota root 2. Iota times root 2, you can write this as iota root 2. So this is what we can do with iota. We can write any unknown number like this as a known number and as iota. So next what you can do, you can obviously think how we perform all of them. So this much you should know by now what natural number, integer, rational, irrational, and real and complex numbers are. So after that let's go to integers. So integers are basically, they have a size. 2 to the power some size they have. If you write them as base 2, so they can be written as some base. Base 10. So for now what we are doing, we are writing them as base 9, 10, from 0 to 9. And what we are doing, if you want base 2 to represent these numbers, so what you can do, you can create some logic over here, and then you can write those numbers as base 2, but the condition is they should only contain 0 and 1. Obviously you can see from here 0 to 9 are your base 10. So there are 10 numbers with which you can represent everything. Basically 1 9 is also base 10 because it can be represented as 1 and 9. So what do we do over here? 1 times 10 plus 9 times 10 to the power 0. So we write it like this. Am I right? I think I'm right. So if you write something like this, 1 9 base 2, sorry, not 9. If you write something like this, 1 0 1 base 2. So what you're doing, you're basically writing 1 times 2 to the power, let me write it from right hand side, 1 times 2 to the power 0, as we wrote over here, 9 times 10 to the power 0, plus, obviously this will be your 10 plus 9, which will be your, I think it will be 19. I don't think, I know it is 19. So over here we have 1 times 2 to the power 0, and then we have 0 times 2 to the power 1, and then we have 1 times 2 to the power 2. So in terms of base 10, we can write it like this. which will be your I think 4 plus 1, which will be your 5. So 100 is your 4, 101 is your 5 in base 2 obviously, and this is in your base 10. You don't write anything in base 10 as base 10, you just write it directly 4 5, at least in common world you write them directly instead of writing base 10 as well. So this is your base 200. 100 with base 2 is your 4, 101 with your base 2 is 5. So we are only familiar with 1 and 0 in our base 2 format of representing numbers. Now suppose if you want to represent decimals with this, let's not talk about that for now, and not even negative numbers. Let's first understand how we can implement this in our C++ library or anything. So at first we have this. Then what we can do, obviously floating point numbers, which is your decimal. So for now let's not talk about that. Yes, so I was talking about size, right? So for integers you have 2 to the power 32. That means you can write 1s and 0 as 32 times. So this with base 2 you can write 32 1s and 0, 32 1 and 0 inside this base 2. And if you want to include negative numbers, obviously it will go from negative to the power 31 to the power 31 minus 1. Minus 1 because you also include 0 over there. So this is your limit, or you can say range for integer and all. Next what you have infinity. Obviously infinity is not a joke. So how do you think you can represent infinity in a in your that, what do you call that, in C++? So to represent infinity in C++, what you have this numeric limit. Basically your infinity is not the real infinity in C++. Infinity in C++ is not the real infinity. Obviously you can count and read that, but suppose for compiler, what will be the infinity? I mean, your compiler knows from 1 to 30 what will be infinity for it. Anything beyond 30 will be infinity for it, right? So 31, 32, 33 are considered infinity for this C++. So just add 2 over here and add 0, or you can, yeah, so you can write 2 to the power 0 to the power 32. Then you have infinity as 2 to the power 32 plus 1. Okay, so let's write minus 1 over here. Then you have this as your infinity in C++, obviously. Now suppose if I say that this is your infinity, obviously you can read this as well, right? But what we interpreted, that this is a function, a symbol for infinity, which tells us that there exists something like infinity. So now suppose if I say that humans can read from this number to this number. Obviously we can read all the numbers. We'll just have to convert them as Zeptalian and all. We just have to say it like that. But for infinity, we just introduced a symbol which can't be read, it can be read, but you can't interpret anything from this. If suppose someone says this is 8 horizontally, then obviously you know they are fooling around. So we use this infinity as a symbol to mark something which we can't read. So similarly in C++ we have this numeric limit, or you can obviously define that directly, but that will be like problem in a way. So suppose I have this double infinity equals this numeric limit, and then you can write double. Then what you can do, you can write infinity over here, which will give you some value. So over here our symbol infinity is this. numeric limit double infinity for double obviously. We can take for int as well, just write int over here. But yeah, for over here you have infinity over here. So let's try to print this out, what we'll get. So over here I can write so I don't remember what library we used to use for this. So let's try directly. I mean, it'll directly show what library we need. So numeric limit and then double. Oh, so it should be limits, I think. Limits double, and then we have infinity over here. Yeah, so this looks good. Obviously I can expand this over here and I can remove this. So let's try to print that out. Okay, so oh sorry, I forgot to write the variable name. Okay, so numeric limits is not defined in this. So let's see which library we need. Let's try algorithm. Maybe in that we have. Okay, so it's not there in your algorithm library. So let me just check where we have this numeric limits and then come back to you. Okay, so we have a limits library. If yeah, so I mean, you can always check which library you have for these things. And over here we can just do /main array. I mean, we can also use array to define this, but we don't need that for now. Also, we need to output this as well. So we have this inf as our that double value. So instead of getting a number or anything, we just got infinity directly over here. So that's a good thing. Just like the symbol, we have inf as our inf as our that thing. Suppose I write a over here. I mean, few of you might have been confused, but you all know that we can't directly write a variable name and see out that. So yeah, so we are getting inf as well because our infinity is stored in this whatever this is, this symbol you can say. And similarly for nan you have let me write inf over here. Basically so let me write that on the on a different line, because we can write that in the similar line, same line, but obviously if I write that on the same line you won't be able to read that. So instead of directly writing nan, let's try to check whether it is a nan is basically not a number. So let's try to check that whether it directly compares that or not. So yes, let's go. Now suppose if you have 0 by 0, obviously that's not a number, it's undefined. So we want that, or square root minus 1 is not a real number. So at first Let me include maths over here. So over here we have double number equals let's say square root minus 1. Actually not write this as number, just take it as a variable. Otherwise it might sound like we are actually trying to print a number and it's not a number. So I mean it's messed up. Square root 1.0 sorry minus 1 0 obviously. So we have this. Let's try see out this x. I mean let's save this, and then what you can do, include math. Wow. So I think it's maths instead of math. Oh, so maths is also not a library. I think algorithm is our library. For now, let's keep it like that. Actually, I think I took that from. So math has a library, yeah. So why was it giving error? Okay, let me check in the notes what our library is. Oh, so it's C math instead of math. And no S over here. Okay, so you all don't have to worry much about that. We'll be writing algorithms. So obviously it's minus nan. I don't know why it's minus nan because obviously we. Oh, so it's minus nan. That's fine, I think. Well, actually, it should have been nan in general condition. So what should I do? I think it's taking some C++ from after 17 or anything. So anyways, so let's write instead of writing this, now let's write nan directly. So if it's nan, then suppose it's not a number, right? So let's try doing this. So if it's not a number, what do you think the output should be, true or false? Obviously the output is your false, which is your 0. Now why do you think it's false instead of 1 or true? Obviously because it's not a number and nan is never equal to anything including itself. So you have to remember that nan is not equal to nan because you don't know what it is, right? One nan can be something which is not your another nan because they are undefined, and something which is not defined can never be equal to anything including itself. I mean that's just a logic. Otherwise obviously in the compiler if you write nan equals nan double equals to nan, in compiler if you write this, then obviously it will show 1 instead of 0. So it all depends on how your compiler has been written, how its backend or engine has been written. So obviously I'm doing lots of error today. I don't know why, including the CMath and algorithm and limits obviously. Because I mostly include bits/std c++.h library, but over here we have to include every library. So I've actually forgotten much more than anything. So obviously you remember that nan is not equal to nan. So if an interviewer or if anyone asks you, can you like see out this as false? You have to remember that there can be nan which you can do. So yes, so that's basically what you'll be doing. So after this, we have understood everything about natural numbers. Obviously binary representation I've already told you now, and you have this infinity and n. So what all we have studied: natural numbers, integer, rational numbers, irrational number, real, complex, binary representation, floating numbers, which are your decimal numbers, and then infinity and n. So let's try to move to some exercises. uh, instead of writing Instead of doing some exercises, let me just develop a few more course work which I'll be teaching you right after pausing this. So let me come back over here and then teach you more about libraries building for data science, obviously. Okay, so I'm back. Let's continue the number theory part. So we so we did nan and all. So let's move to fractions now. Obviously rational numbers you already know. But over here we have proper, improper, and all fractions. So for proper fractions, you have your p less than q. Yes, it can't be equal. You say p less than q. And for improper fraction, improper, obviously p by q belonging to q. P belongs to integer, and then you have q not equals to 0. So p less than q. Improper fractions, you have this p greater than equals to q. Yes, so your natural number can be considered improper fraction. Obviously it can be 0 as well, so that will be your whole number. So next we have obviously equivalent fractions. Wow. So we have this. Suppose you have p by q. This will be equal to your 2 times p by 2 times q, because 2 and 2 can be dissolved. So you can just write this. Or let me directly write 2p by 2q. And similarly for so np by nq. So this will be your equivalent fractions which are equal to each other. Next you have how to simplify a fraction. So this will be your simplifying a fraction. Obviously everyone knows we have to write code for this, simplifying a fraction. So that's the reason I'm highlighting this. So simplify a fraction. You have this 18 by 24. So after this you have this will be your equal to 3 by 4, but you have to write the steps. How do you get 3 by 4 directly? Obviously it is your GCD for 18, 24 as your 3. Sorry, it is your 6. So which will give you 3 by 4 for this fraction. 6 times 3 and by 6 times 4. So you can just remove 6 and 6 from up and down, and then you will get numerator and denominator as 3 and 4. So this is your like simplifying a fraction. You need to find a GCD. So how do you find a GCD? Let's try to trace that as well. Or instead of tracing, you have a function in C++ which directly gives you GCD. So instead of wasting our time, we'll be just directly writing GCD of this and this. Number 1, comma number 2. Now suppose if there are 3 numbers, you want to find GCD of 3 numbers. Obviously you can directly write this, or there might be a possibility that it takes set as well. But for now you have to check whether by using 2 numbers only. So how do you think you'll be doing that? So GCD of num1, num2, let's suppose 3, 4. You'll get this as greatest common divisor. Yeah, so you'll get 1. Obviously let's take something different. 18, 24. You'll get 6 as the divisor. And suppose this is your okay, so let's write 3 over here. 6, 3. So you'll get 3 as your other GCD. So you obviously have to do it twice. So that will be so that you will be storing GCD for one, and then you will be finding GCD with GCD of the other. That will give you your GCD of all 3. So this is one approach, or otherwise if there is something like GCD set of this, then you can find directly by that. And if there exists a function like that, so you have these things. So after this, let's implement this in our code. So actually, I didn't tell you that you can write, instead of writing this, you can also write. So what you can write over here, you can write the nan function over here, which will give you a nan number. So let me write that. Okay, so instead of writing this, I'll be writing this over here. Yeah, so this is your nan and that will be your infinity. So you got both the things. So these are your two things. Next you have to go with the function. Well, instead of main, what you can do, you can write this as library.cpp. We'll be using this library later if we need, obviously. Or you can just include this as a header file and then we'll be extracting those functions from there to there. But yeah, you can you have to just make it a library. So you can just do library.cpp. That will be good. So next we have where was I? Oh, so we had to simplify the fraction. So for simplifying, obviously you need to write this include numeric. So instead of returning a single number, let's return two numbers, which will be using parent command. Obviously, if you have studied from DSA course of mine, you already know what this will be doing. So yes, so I'll be returning a pair, which will be your parent command. So after this, what you can do, you can just take GCD of those two numbers. So let's store the GCD as G, or if there were suppose more than one number, so obviously you can just do it from here. Obviously, for simplifying a fraction, you don't need more than one or more than two numbers for the GCD. But yeah, if there are more numbers, you can just do with the method which I told you. So we have got this GCD, and then final answer equals your PYQ. So not PYQ, PYG, comma QYG. So I don't know what just happened over here. Let's try this. I think I pressed some key which made me go over there. Anyways, so we have this, and then we have. Oh, so I didn't see out anything. Okay, so instead of just returning, we can just do this as well. Or we can instead of writing anywhere else, we can just write it over here. So as you have seen, I'm not using end line over here because that flushes our DNS. So I'll be just using the /n. So for that, I'm just for the safety measures, I'm just using this instead of end line. So let's run this. Okay, so wait. So we got 3 and 4 as the answer, which will be your 3 by 4. Obviously, if I wanted, I could have just done this. It'll just give you exact fraction. 3 by 4. Yeah, we got that. So afterwards, so let's go to the next topic now. So simplifying fractions, we are done. Let's say we want to add simplified fractions. Obviously, adding. Let's first see how we add the fractions, and then afterwards we'll be moving to adding simplified fractions. Obviously, adding fractions. So at first you have this 1 by 3 plus 1 by 4. Let's say we have this. Then obviously you have to take LCM for this 3 and 4, which will be your 12, I think. Yeah, so this will be 4 plus 3, which will be your 7 by 12. So you got this. So after this, what you have? You have like general formula, which will be your this times this plus this times this, and then you can simplify the fraction. By that, what I mean is, let's say you have 4 plus 3 by 4 times 3, which will be, in this case you got the same result, but suppose if you're given something like this, your 1 by 4 plus 1 by 8. Obviously everyone knows that you can just directly do it like this, but let's say we want to add it with 8 plus 4 by 32, which will be your 12 by 32. Then you can simplify this, I think by 4. Yeah, so 4 3 12, 4 times 3 is 12, then you have 4 times 8, which will be your 32, so it's 3 by 8. So you can just use this formula, AD plus BC by BD, or A by B plus B plus C by D. So you can use this formula, and suppose there are more than 2 of them. So at first you can use this and then simplify. You'll get something like this, E by F. Then what you can do, you can just instead of writing E by F, let's write A1 by A2, or let's write PQ, P by Q. Then you have P by Q, which will be your A by B plus C by D. This will be your this plus E by F equals A by B plus B by plus C by D plus E by F, which will be equals to your PF plus EQ by Q plus F. And obviously for subtracting, you'll just write minus over here. So this is your plus, and that is your minus. So this will not be your Q plus F, it will be your QF. So you have this formula, and for minus you just introduce minus over here. So we have this, and for multiplication it's obviously very easy, 2 by 3 times 5 by 7, or instead of writing this, let me write 1 by 3 times 3 by 4, which will be your 3 by 12, and on simplifying you'll get 1 by 4 as the answer. Well, obviously if you directly cut this, you obviously get 1 by 4 as the answer. So this is how you use simplification everywhere to make your life easy. So that's how you use this simplification in everyday life. And for division, you obviously know that you will be just using inverse of the fraction divided by 1 by 4 divided by this equals 1 by 4 times 4 by 3, which will be your 1 by 3. So you just inverse the fraction 1 by 4 times 3 by 4 inverse, which will be your which will be your this. So basically inverse is your power minus 1 in case of numbers. In case of matrix, you already know what it is. So you have this decimal representation also, you know. So obviously let's talk about data science now. So rational numbers in data science So you have rational numbers in data science. Imagine a data set of 200 numbers, 200 strings, or you can say that you have to imagine there are 200 strings in a class and 150 passed. Out of 200, 150 passed, and the pass rate you have to find the pass rate for class. So you have like 150 by 200, which will be your 3 by 4, which is equals to 0.75. Now suppose fractions only define your obviously ratios and probabilities. So suppose you want to predict something. So for a classifier, it predicts. This is just an example. Suppose there is a classifier which predicts correctly on 98 out of 100 examples. So you have accuracy equals 98 by 100. Obviously it will just drop to 0 in terms of ML and AI if they haven't seen anything, and they are given like you bring a concept which is completely new to AI. Obviously it will be able to solve by mixing few things like dataset, a few things. But suppose if you know how the algorithm works at the backend, so you can take this element and the last element, which you know that instead of combining random, obviously it combines randomly, which you know that out of 4 times, it will miss for 3 times, because you know how its randomness works. Yes, so what I want to say is basically if you know the random function, how it works, then you can just find that how much error it will actually give. So it's not just based on one thing, it's based on multiple things. So I can't just tell you over here, I can't just explain you directly. So obviously it depends on randomness, it depends on how the data has been given, it depends on how it will be set for a reading for your ML or other stuff. So it depends on all that. So for now you just have this 98 out of 100. So obviously this will be your 98% accuracy, you can say. Accuracy. So let's go with the mini challenge. You have to write a function in C++ which adds, subtracts, multiplies, and divides, which does all these four things. Obviously you have your simplifying fractions that you have in your hand. So just write these 4 functions. So let's begin. If you have already written it by yourself, that's well and good. Otherwise you can just copy it from here. So let's go with addition. Obviously you have to return that rational number, not a decimal or anything. So let's start. So instead of writing everything again and again, I'll be just pasting this over here. and we have this add function, add fractions, and then we'll have pair of. So you have two numbers x and y. So there are multiple ways you might uh, do this, but I'll be just using this method, which will be your first simplifying. Obviously it will take some time, then you will add, then you will re-simplify that, or you can just directly do it like instead of simplifying again and again, you can just directly do it by using multiplication and all. But obviously you have int as the range, so it's better to simplify first and then multiply. I mean, obviously you know why it's good if we are talking about the range. So yes, so we have this parent command y, and then we have int p1 equals x dot first. So what I'm doing is I'm just taking this x dot first, which will be your first number in the first fraction. Suppose if you have x as 3 by 4, then p1 is your 3 and q1 is your 4. So for 3 by 4 we have 3 and 4 over here. So obviously GCD, instead of writing, oh sorry, I wrote wrong over here. I should have written simplify fractions. So instead of writing GCD, I'll be writing this. So we are simplifying x and y at first, and obviously they are pair, so you don't need to worry much about them. So we have written p and x and y. Now they are simplified. Next you have to just add them. So for adding, you already know what you have to do. So this will be like you can rewrite this. So instead of rewriting, I'll be just copying and pasting this. So you have got your simplified p1 and everything. So just add, obviously. So to add, you have this p equals, I think it was, let me see the formula first. Okay, so it was p by q, and then this. Then you have ad, which will be your p1 q2. p1 times q2. Then plus, it will be your p2 times q1. And then for q, you have this q1 times q2. So obviously we can just see out directly over it, or we can just simplify, that will see out everything. So we can just simplify p and q over here, simplify fractions. Obviously we need to return it to something. So let's say we have pair int command simplified or added. result. You have this. And return. Yeah, so we are good to go now. So at first I'll be just removing this. I'll just add fractions. And then I have to give parameters as pair. So I'll be using this curly brackets. Then for x, let's say we have 1, 4, which is your 1 by 4. And then say we have this 2 by 8. So yeah, this should be our answer. If there's any error, obviously it'll show it over here. Okay, so we do have some error. This is a comma. I forgot comma over here. So obviously I forgot comma over here as well. Then I think there's no more. Okay, so yeah, so this much was our error. Let's rerun this. Oh, so we have 1 by 4, 1 by 4, and 1 by 2. So this is your p by q, and this is your obviously p2 by this is your x, this is your y. 2 by 8 is basically 1 by 4, and then you have this answer 1 by 2. Let's say if you want to do some more calculations. Let's say we have this vector we have this, and then we have numbers, fractions. Let me write equals. Instead of directly writing this, let me just take this over here, and then we have this 1, 2, 2, 4. So let's say we have all this, and afterwards we can just instead of doing this over here, just have fraction, or I can say result. Oh no, there is no need for any result over here. Or yeah, there is. Let's say we have this result, and then we have n equals 0. Then fractions dot size plus. Obviously, if you use plus I, that will be better. Obviously, everyone knows why. I've already told you about this in my research. So you can just watch the research video as well if you need. If you want, obviously. So we have our result. So instead of writing directly, what we'll be doing, we'll be writing result equals result. So for addition, add result, we can say. For this, what you can do, you can write 0, 0. For multiplication, you will take 1, 1. For division, obviously, you will also take 1, 1, and for subtraction, you will take 0, 0. For result, we have the result equals to result. Instead of writing result, I'll be writing this. Add fractions. And then over here, I'll be adding everything 1 by 1. So it will be result, comma. So result will get input as x, and y will be your this pair from here. So we have fractions I. Yeah, so that will do our work. The fractions I over here, And yes, it looks good. If there will be an error, it will just directly pop over here. So let's hope. Oh, so it was fractions, not fraction. So yes, now it looks good. Oh, so it was add result. I am sorry, I didn't see that. Is there any more error? Obviously, I'll be checking that. Yeah, so this is, I think this is the last error. Add result. Obviously, you should always check everything, but I don't know why this is happening. Let's say we have parent comment add result, and we have this. Oh, so it looks good to me, but for some reason we are not getting the right answer. Oh, so let me just quickly check everything. We have this vector parent in fractions, which will be this and this. I think it was declared well. I mean, what kind of error is that? So we didn't use semicolon over here. That was the problem. Okay, so where's the answer? So we didn't get any answer for some reason. Wow. Okay, so we are not getting anything. Okay. See out this, which we have to see out anyways. So this was 0, 0. Let me just quickly check what is the problem. Okay, so we don't have any error over here. So let's try to first see out fractions over here. Let's comment this out. Obviously, this is part of debugging. Okay. Oh, sorry. So we have 1321, which is correct, and we have second as well, and fraction size is your pair. So I don't know why this is not giving us the answer. So let me just this will be your. So instead of doing any nonsense over here, let's just do this and see whether we are getting anything. Okay. It's a big list, I would say, because it was a pair, obviously. I don't know why I keep writing fist instead of first. Okay, so let's run this as well, and we have one as the answer. Okay, so for some reason we didn't print this, we just directly print this. Maybe it's some problem in this Google Colab, I would say. Okay, so why is this happening? I don't know why this is happening. So actually, I'm actually confused. Let's try to add this ourselves directly. So we have this 1 by 2, 1 by 2, which is your 1, and then 3 by 5 plus 1 by 8. Obviously, it's greater than 1. So it's this answer is wrong. And also, it wasn't supposed to. Okay, so we didn't write this. Obviously, it's not printing many things. So okay, so we are not getting any second. Let me refresh this. Let's cancel this, and then we have. Okay, so I didn't save that. I think that thing wasn't saved. Oh god, now we need to write all the things. Actually, that code was there, but these things have to be written again. So instead of writing everything, I'll be just writing this over here. So I think it was G++. So dash. Sorry. We have to find the path name. So I'll be writing the path name as well. Let me just first write this. And in the new line of code, I'll be just doing this not dot slash. Okay, so we have this. And over here we have okay, so we are still having the same problem. I think there is some library problem or something like that, or what? No, actually, libraries are good because we just printed everything. So it's some problem that I don't know what the problem is. So there's fractions I, which is your vector I, which will be your parent comment, which is just getting in there. So I think everything is correct. So, okay, so let me just change this and write it over here and save this. After this, we can just. So it's giving 0,0 over here, and it's also giving something like 1 for some reason. Let me check if I've done something absolutely wrong somewhere. I don't think I have done anything wrong anywhere. Actually, let's just think this. Let's just fix it or not. So basically, we return false at the end, so that if this fixes, then we are good. Okay, so that didn't fix anything. Let's remove this. Simplify fractions. Okay, so just wait. We have this control slash. Let me write this. I don't know what happened all of a sudden because we're getting everything right, but now we are getting everything wrong. I mean, we are not getting anything. That's the issue. So what you can do is let me check something. Let's see if that fixes something. Okay, so we are actually getting something even worse than that. So let's change that. No such file or directory. What? Just please wait. I'm just actually I'm curious why this is happening. Okay, so actually we cannot see main over there. Wow. So content. We don't have any main function over here. Wow. And main file. Let's try to see that. And we can't see our data science as well. Okay, so that's actually okay. This. So I don't know where course headed went. Wait, if it doesn't exist, how did I open this? Wow. Actually, it's crazy. Let me just quickly check. Copy path. Okay, so for some reason we need to refresh this. Let's check if everything comes back or not. And I again forgot to save that. Oh, great. We actually lost everything. We don't have a C++ even after doing all that. So obviously we need to solve this. Let me just quickly actually, instead of writing code again and again, we can just try for a backup, I think. So I think I wasn't supposed to save anything over here. I think I was not supposed to. Let's try saving a file over here. Yeah, so sometimes this might happen. So what you can do, you can just actually I should have just copied that main.cpp instead of directly refreshing everything. So what we can do, we can just directly write this as fast as possible. I mean, you already know that. So let's move to, we have to just show that addition. At least I can show you. So we have this. We have p as your x dot first times x times y dot second. That's x dot second, I think. Yeah, times y dot first. So we have this, and for q we have uh, x dot second times y dot second. So basically we have answer as PYQ, which will be your simplification of. So we're gonna turn the answer. Yes. So we have this. Mostly we need to include everything else. Yeah, so this looks good. Now we have just a vector there, and comma n, and then you have v equals your 2, 3. Okay, so this looks good. Let's just copy this path, and then we have so okay. Let's see if there are more errors. Everything was on line 7, so yeah, we are good to go now. So we can't just directly do GCD or what? So I forgot numeric library, I think. Yeah, so we are now good to go. So let's save this. Let's run this. So no such file or directory. Okay. Okay, so this should be slash main, I think. No, actually, it should be main dot slash. What's happening? Okay, so this is our answer. So instead of writing over here, I'll be just going to code chef compiler. I'll be fixing this later. So what you can do, you can just check this over here. If we are getting the answer right, then we are good to go. Otherwise, we obviously don't need anything. Vector parent comment, which is your vector. So we have to include. Okay. So instead of writing that, it's just throwing different kinds of errors. I mean, it's not showing any error. That's very good. So we have this. So let me just check why we have this. So we should have got some answer, right? Answer should be it's not extra. Sure, that's right. Over here we are getting some runtime error. Let's say if I do integer. So we are still getting runtime error. So we have this vi as parent. Actually, this is the first time that I'm this much confused. Let me just try this. So let me just slash. So this is your v0 v1, which will be your 1 by 2 comma 2 by 3. Okay. So let's run this again. Oh, okay. I never just printed anything. So actually, I did print over here, I think. Okay, so we are getting correct answer. But for this, I don't know why we are getting answer is wrong. So I don't know what to do. Let me try it once again. We have added that. Let's just consider this thing. Oh, now I think I get it. Okay, so okay. Actually, 0 by 0 is not a rational number. If you just if you just try to think, which I gave over here, so that is actually wrong. So let's try to give this as the answer. So 0 by 2, which will be your 0. So 0 by 0 is actually wrong. So I don't know why I was doing that. Yeah, so it was an error from my side. Yeah, so we got the answer. It might be correct. I don't know. I just didn't calculate. So it was never a problem of Google or anything. It was just my mistake. I'm so sorry for that. Sorry for wasting your time. I think today I'll be just ignoring that I did everything wrong. Sorry everyone. Sorry for taking too much of your time. Thank you for watching. Let's meet in the next video, and then yeah, we can just come back over here, and then we can just do some fun stuff. So save these two in some library.txt file. Save these two, and obviously for subtraction, multiplication, and division, you can just save them as well. Those functions have to be saved. So thank you for watching. Thank you everyone. Let's meet in the next video. Thank you.